Hello everyone, today I'll be showing you how you can make your own slide puzzle with all kinds of different options that you can modify. Um, as you can see, we go into play mode, you can hop on the puzzle, start clicking it, and it moves around. And when they get into the right position, we get true up here, which shows that we've got it correct. Some of the options that I'm going to be implementing here is you can change the grid size, so we can bring this down to say 3, they get bigger. Blocks actually get bigger, and there's only 9 blocks here now. Or I can crank it up to say 10, and then there's a whole lot more blocks that you can play with. We can also do a shuffle feature, so it mixes up all the blocks. And we have this desired size here, which will control how big the overall puzzle is itself. So I can change that to say 1,000. We get a really large puzzle, which should be 1,000 by 1,000 for size, or we can take it down to 100. And as you can see, it's only 100 units wide. It's the same size as the floor. Other than that, we have texture that we can change. And yeah, that's about it. Let's get started. Alright, so to begin, the first thing I did was create a new player controller, and I set it to show mouse cursor and enable click events. This is going to enable us to just click right on the blocks when we create them, and that will be how we control the movement of them. I also went and overrode the game mode here, just so we could use the player controller that we want to use. So hit play, you can see we can just move around and I can click things. Simple. Alright, so the next thing we need to do is create a new blueprint class. Type actor. I'll call this BP puzzle. Alright, I will open that up. The first thing we're going to want to do is be able to spawn the puzzle itself. So let's create a new function for that. We'll call it spawn puzzle. Alright, since we're making a function, we can call it either from begin play or in the construction script. So just to make things simpler later, so we move it around. Alright, so the first thing we want to do is create our blocks. So we need to know how many blocks we want first. So we'll create a variable, and we'll call this grid size. And we'll make that a integer. Alright, so we take our grid size, and we're going to run 2 loops, one for the x direction and one for the y, and that way we can create a large grid. So we'll get a for loop, and we're going to subtract 1 from this so it's easier to understand once you're done with it. We'll make that the last index, and we'll copy that, copy the for loop, and we'll plug the same thing in, the last index. Alright, so the first one's going to be our y index, and the second is going to be our x. So let's promote those to a variable. We'll connect it up, and we will call this y index. And we'll do the same for the x. X index. Alright, so now we have a nested loop, and we can create a grid pretty easily from that. So let's start by adding some collision. This will be just a little collision box so we have something to interact with and we can know where our blocks are. So for that we're going to need our x and our y index. And we're also going to need to know how big our mesh is going to be. So let's create another variable. Call it mesh size. And let's make this one a float. Alright, so now we need to do some multiplication to tell it where we want our meshes to spawn, or where we want our collision box in this case to spawn. So we'll just do a int times float. Int times float. And we will multiply both of these by the mesh size. Alright, now we need to add a collision box. So add box collision. We'll split out the struct bin, and this is all relative transform, so that's really makes things simpler. For our location, we'll just split that pin in two. Split struct bin, and we'll get our Y location and our X location. Just reorganize those real quick. Alright, so right now that should create a grid for us if we drop in the level. But we have to be able to call it first. So we'll call it on begin play. We'll call a spawn puzzle here. And so when we start the game, that should create some boxes. One thing we should do, just so we can see them, go to our add box collision, and I'm going to set these to visible, or not hidden in game rather. Alright, so now if I press play, nothing shows up. Amazing. Yeah, something went wrong there. Oh, I never set our mesh size. Silly me. Alright, I'll set that to 100 by default since that's the size of the default cube. Let's try this once more. Still not working. Alright, this is really something wrong. Oh, forgot to set the other variable. Oh, I'm forgetting all sorts of things today. Alright, let's try this once more. There we go. Now it's working. You can kind of see it there. Now we have a 3x3 grid of boxes. Alright, now we're cooking. Alright, so I actually want those boxes to be 1/4 of the size of our mesh that our future mesh is going to be. So we are actually going to take this output bin and say set box extent. Set box extent. Alright, now we can just plug in a vector to that. And for that, we're just going to use the same for every axis of the vector. So we're just going to split the struct bin, and we're going to take our mesh size, and since we want it 1/4 of the mesh, we'll just divide by 4. Vector divided by float, nope, that's not what I want. Float divided by float is what I want. So take that, divide by 4, and we'll plug that into all of the axes. Alright, and so now that should give us much smaller boxes. Yep, they're a bit smaller. Alright, so the next thing that we need to do is we want to keep track of all those boxes so we have reference to them. So let's create a another variable, and we'll make this of type primitive, I believe. Primitive component, object reference. I'll make it an array. And we'll call this spaces list, I guess. These collision boxes are just basically keeping track of where possible move to spaces are. So we'll get our array here, and we want to add an index. So we'll just say add. And the index that we want to add is this return value. So we will clean this up. Alright, so now let's actually spawn our meshes. So we're basically going to repeat the same process here to get our meshes. But as you know, for a slide puzzle, you're going to have, if you have 9 total spaces, you're going to have 8 possible meshes that you can move. So we're going to have to subtract 1. So we're going to do a little branch here, and what we input to this branch will determine which spaces actually get spawned. So we want, say, all but 1, so we're going to do, we're going to get our puzzle grid size. We're going to subtract 1. And from there, as long as our x and y don't equal that number, we want to spawn something. So let's get our y and our x. And we'll say that y index equals this number. And we'll do the same thing for the x. And we'll use an and here. And Boolean. And plug that into the branch. Alright, so if our grid size is, say, 3, we'll have 2. If x and y both equal 2, that will be the last space that's created through all of these loops. So it's basically just saying we're not going to create that last block. Alright, so let's move this over. And from there, we can start creating our actual meshes. So we're going to add static mesh component. We're going to do basically the same thing, so let's just come over here and actually copy that. We're going to split the struct bin, x index, the y index. Alright, and let's set this mesh to 1 meter cube. Connect it to the false bin. And without doing anything else, that should spawn our meshes. If all goes well. And hey, there we go. We've got one big lump of meshes missing a corner. I'm going to set the scale on these to 0.9, just so it's better, so it's easier to see. Hit play again, and it didn't do it. So it's actually the relative transform, I guess. Compile, play. There we go. Now you can see we're missing just that one in the corner. We've got the other 8. Alright. Now I'm going to set these back to normal, just so we don't have to worry about it later. Alright, and we also want to be able to keep track of all the meshes in the same way that we keep track of all the spaces. So let's duplicate that, and we'll call this meshes list. And we need to change this type to static mesh. Static mesh object reference, and we'll just add to it. Get, add, oh, wrong type. Oh, static mesh component, okay. So let's reassess here. Say static mesh component, not just static mesh, object reference. Change variable type, yep, that's fine. And we can plug that all up. We're good to go on there. Alright, so now we have a list of all of our meshes. Alright. Now, should have the same thing going on, yep, okay. But that looks pretty bland, you can't tell what it is. Obviously, for an actual puzzle, you need some inclination of what shape it needs to be, where the pieces need to go, so we need to add some material to that. So let's go create a material. We'll call it puzzle material, or m_puzzle material. And we'll open it up. And alright, so we're going to need to work with the texture coordinates for this material. So we will say hit U and then click for texture coordinate node. And we're going to be dividing this texture up just so we can basically scale it. We're going to give each individual tile its own section of the texture. So we're going to need to divide this. And then we need to add it. Alright. And then this is just getting us the correct coordinates of our texture. The divide will divide it into sections. Say divide the whole texture into 3, and then the add will tell it which section of that 3 we want. You know, part 1, part 2, part 3. And then we got to get an actual texture. So we got texture sample. Let's promote this to a parameter, and we'll call it puzzle texture. And we'll input our UVs. And that's going to be our base color. Alright, so now we need to actually fill in what these things are being divided by. And we're going to, it's all going to be parameterized, so we can change it on the fly depending on our texture, how many pieces we have and all that. So I'm going to use a vector 3 to control all those amounts. And we'll use the R, G, and B values to control the different parameters. So this is going to be texture offset, or control all of our offsetting. So we'll call it texture offset. Texture offset 2D. Alright, and the first two we're going to make into a float 2. Make float 2. And plug that into the add. And then our divide will be the blue value. Alright, and that's basically it. We just need to give it a texture. And I don't really have any good ones. We'll go with the UE4 logo for now. And yeah, that should be good. So hit apply. And let's go back to our puzzle. And here we just need to set all those values. So let's get a reference to our thing. Let's get a reference to our mesh, and we will create a dynamic material instance so we can change all those parameters. Dynamic material instance. And the source material will be our puzzle material. And we'll connect it up. Alright, now we need to set texture parameter values on these. So we'll drag off there. Set texture parameter value. And we need our parameter name, which was puzzle texture. And the value, we are going to make that a variable, so we can change it on an instance basis. So we'll promote that to a variable, and we're just going to call it, I don't know, texture, I guess. Keep it simple. Alright, and the last thing we need to do is to split up our material. Basically set all those values that we set into the vector 3. So we're going to set vector parameter on materials. Let's bring that over, connect it up. And our parameter name was texture offset 2D. Hopefully I spelled that right. We're going to split the struct bin so we can set each individual one. And so for that, we're going to do a similar process that we did for creating the meshes and setting their locations. We're going to need our indexes. So we'll get our X and our Y. And we're going to multiply each of those by a float. Int times float. Alright, and then we also need to base it off of our grid size. So we are going to get our grid size, and we're going to do some division here to basically decide how much each block will take up of the entire grid, or at least in each axis. So, so if we have 3 by default, it'll be 1/3 of the puzzle. So we'll just do some division here. We actually need to convert this to a float. So float, and basically we need a float because we're not doing whole division. We want to be able to get, the decimal forms of things. So we'll take 1 divided by our grid size, and we'll plug that into our multiplication here. And we're also going to use that same number for our third value. So now we can just connect up all of our values. It's x goes to x, y to y, and z will be this other value here. Just do a little cleaning up. Alright, that looks a little bit nicer. Alright, so if we compile, we should be able to hit play and have, oh, that's not quite right. It shrunk our texture for some reason. Alright, so I found my issue there. Turns out that I was using the wrong mesh. Before I said use 1 meter cube, but you actually need to use the regular just cube. I didn't realize they had different texture coordinates on them, but apparently they do. So now when you hit compile and then play, you can see that it actually projects correctly now. So that's just one thing you'll have to be careful of when you actually do your own meshes and things. Alright, I think that's it for this section. I'm actually going to add a couple more things here. First, we need to know when this is all done. So when we actually call it in our graph, we can actually have an output. So we'll just do a return node here. And I want to be able to run this on the construction script. So we need to have a way to clear all of the old data every time we want to create new blocks and things. So for that, we'll just need to get our spaces list and our meshes list. We're going to destroy everything in both of those lists and then clear the lists before we actually create more objects. So for our spaces list, we'll do a for each. I'm actually going to do a reverse for each, just so we start at the end of the list and kind of solves any problems you might have. So we're going to destroy component, and then once that's done, we're going to take our spaces list and we're going to clear it. So on complete, clear. And then we're going to do the exact same thing for our meshes list. So we'll do reverse for each, and we're going to destroy the components. And we clear the array. And from there, we can start our for loops. Just bring that up, make it look a little nicer. Alright, so now that that's all clearing everything out, we can stop doing it on begin play and actually do it on the construction script. Let's spawn here. Alright, we'll hit compile. And as you can see now, it just shows up and we can move it around. We don't have any issues. If we didn't clear that first, we would create multiple instances of this. Every time we moved it a little bit, one little unit, it would create another copy of everything. So instead, we'll destroy the old stuff, create new stuff. Yeah, that's pretty much it for the spawning portion. Next, we'll move on to actually shuffling up the meshes, basically. Alright, so for the next part, we're going to handle shuffling of our meshes, and it's pretty simple actually. Let's create a new function. We'll call it shuffle puzzle. And for the shuffling, well, first, for testing purposes, we may not want everything shuffled, so we're going to create a little out for ourselves here. Let's create a variable and call it shuffle. But we'll make that more of a question. And we'll set its type to Boolean, and we want it to be a single value. Alright, so first what we'll do is we'll check this value to see if we should have it shuffle. We'll just do a little branch here. If it's going to be shuffled, then we'll run a script to shuffle it off true. If not, we'll just skip this entire node basically, and we'll do a return. Alright, and for the actual script here, we are just going to get all of our spaces for each of these. We're going to get its location, relative location. We need to get relative location. Alright, and we're going to add those values into another array. So we're going to create a local variable here. We'll call it locations. We're going to make that a vector, and we want an array. Alright, so we'll get that array, and we're going to add each of these relative locations to the array. So we're going to drag off that, and we'll say add, and add our relative location. What we're doing here is basically just making a list of all of the possible locations that a mesh could reside. Alright, so we'll connect that to the true pin. Alright, so once that's done, we need to shuffle our array, just to randomize things a bit. So we will again get our array. It's a handy node for shuffling. Just search for shuffle, and we get shuffle. Alright, and now we just need to take that shuffled list and set our meshes to be in those locations. So we'll do another for each loop, but this time on the meshes list. For each loop. So for every one of these, we're going to set it to a random location. That's basically all we're doing here. So all we need to do is we'll get our locations, and we'll get the first one on the list. Since it's randomized, it doesn't matter which one we get. And we're going to take our array element, set location, set relative location, and we're going to set it to this value. And since we don't want any other mesh to be at that location, we'll simply take the location and we'll remove that index. So we'll remove index 0. And once that's done, there's nothing else we need to do. We just need to create another out to basically tell the next node in line after this shuffle that it's done. So we'll just do another return. Add return node. I'll hit compile. In our construction script, we will add our shuffle puzzle. And we are going to make our shuffle variable public. Just make it so the little eye is visible. This will allow us to change it in the level. Hit compile again, and let's go to our level. We can see our nice smiley face guy here. If we go to our details with it selected, we'll see shuffle under default. And if we click this, it shuffles up all of the pieces. And that's about it. Speaking of public variables though, I also want to make their grid size public. This way we can create more tiles basically. So we can just go to our 5 and create it. We'll handle the scaling later. Alright, so the next thing we're going to do is address the scaling of the puzzle so we can have it set to a desired size. So let's create another function for that, and we'll call it scale puzzle, or puzz apparently. Let's add the L in there just to make it consistent. Alright, so for this scaling, we're going to need a desired size input. So we'll just create an input and hit desired size. Actually, let's make this a variable. I'll make things easier, I think. Call it desired size, make it public, and let's make it a float. Single variable. Alright, so we'll take our desired size, and we're going to have to adjust our current size of everything based on that desired size. So we need to get our grid size, and we're going to multiply that go int by float. We're going to multiply that by our mesh size, which is the size of our individual meshes, obviously. And then we're going to divide them. So we'll take this value here and divide it by a float. We're going to divide it by our desired size. And this is basically just scaling things down. It's very, very simple. We're going to do a vector divided by float. Alright, since we want it to be less than 1 here, we're going to take 1 and divide it by this amount. And then we just need to set our actor scale. Set actor scale 3D. And we'll plug in our value here. And we need a return node. Alright. Take compile. Can't forget to set our desired size. So we'll hit 500 for that, just as a value. Alright. So now if we change this value here, it should. It doesn't because we never called it. So head back to our construction script and we need to call that function. Hit compile. Alright, there we go. Now it's shrunk. So 300, scale it up. If we change our number, it doesn't change size. You can see it's moving a little bit. That's just because the first block is based on the 0, 0 point and we never offset it. So it's going to move slightly. And the other thing that happens is the blocks get thinner the more that you have. So if I just do 5, it'll be twice as thick. So that's just something you'll have to keep in mind as you're working. Yeah, so in the next video, I think we'll start getting started on the actual movement and the functioning of this puzzle. So yeah, thanks for watching.